Earthquakes are one of nature's deadliest forces. We all know what they are. But have you ever wondered what actually triggers them? Today we'll find out exactly what's going on down underneath our feet on today's episode of
Geography Rocks.
First, we have to understand what is going on underneath our feet by looking at the 4 layers of the Earth. From the outermost layer, the Earth's crust, going inwards, the mantle, then finally the outer core and inner core. Now, to understand how earthquakes form, we have to start from the center of the Earth, at the inner core. A dense, solid core, made of iron and nickel. Surrounding this is the outer core, also made of iron and nickel but in liquid form. Both of these layers are incredibly hot, over 5,000 degrees Celsius, over 9,000 Fahrenheit for our American viewers. The way to think of these layers are as the furnaces that fuel everything above them. Moving farther outwards from the cores are the mantle and crust. The mantle is Earth's thickest layer, around approximately 2,900 kilometers thick. The closer to the core, the higher the temperature of the mantle, around 3,700 degrees Celsius, 6692 Fahrenheit. The temperature gradient means that as we move away from the cores, towards the upper layer of the mantle, the temperature continues to drop. It's worth noting the upper layer of the mantle is still incredibly hot, at around 1,000 degrees Celsius, 1832 Fahrenheit. The crust is the outermost layer, made of solid rock. It can be one of 2 types, the continental crust, which is land, or oceanic crust found under the oceans. The continental crust is much thicker than the oceanic crust, but is not as dense. Make sure to remember this for our future videos as it's important for this unit. Put simply, oceanic crust is thinner but more dense. To understand how we end up with earthquakes, we have to go back down to the cores, to the furnaces, at the center. It's all to do with convection currents. The inner and outer core have such high temperatures they heat up the lower layer of the mantle, melting the rock and turning it into magma. Think about your physics lessons with this. Heat rises. This causes the heated magma to rise upwards towards the crust. The farther it rises, the farther away it gets from the heat source of the cores. But from underneath, a continuous plume of hot magma continues to rise, pushing the magma outwards. As the magma gets pushed sideways, it spends more and more time at quite a distance from the heat of the cores. This cools the magma further. As it cools, it becomes more dense and begins to sink back down towards the core. The closer it gets to the cores, it will warm up again and begin to cycle back around as a convection current. So how do earthquakes happen? The crust is broken into pieces called tectonic plates. They are continental, such as the land of the Eurasian plate, and oceanic crust, like the Pacific plate. These plates are resting on top of the mantle, where the continuous cycle of the convection currents drag and move them in their respective directions at an average speed of 1.5 centimeters a year. Now, this may seem very slow, and it is, but think about the power needed to shift and move something the size of an entire ocean or continent. Tectonic plates move due to convection currents in the Earth's mantle, which are driven by heat from the Earth's core. These currents cause magma to rise, move horizontally, cool, and sink, pushing and pulling the plates above. This movement results in various geological phenomena like earthquakes, volcanic eruptions, and the formation of mountains. Join us next time for when we take a look at how this movement in the mantle causes the tectonic plates to interact with one another at the edge of each plate boundary, as they scrape, crash, and move away from one another. Thanks for watching and see you next time on Geography Rocks.
Don't forget to like and subscribe.